This is Dr.Senthil Kumar, Associate Professor, Department of EEE, Electrical and Electronics Engineering. We are sailing in the subject analog electronics. Here let we see the MOSFET, the structure and the operation. The introduction of a MOSFET. What is a MOSFET? The expansion of MOSFET is metal oxide semiconductor field effect transistor. It is a transistor. It is a semiconductor device or a three-layer semiconductor device which is nothing but a transistor where a metal oxide is poured in the top of the device. The MOSFET is a core of integrated circuits and it is designed and fabricated in a single chip. I am repeating that it is a core of an integrated circuit. It is a core of an integrated circuit. It is designed and fabricated in a single chip. The chip is single, it is very small in size, whereas it has four terminals, namely source, gate, drain, and body. The body terminal is nothing but the base. The body terminal is nothing but the base or the plate. Whereas only the three terminal exist: source, gate, and drain. The body is almost frequently connected to the source since it is act as a base, right? Why MOSFET? Particularly, the MOSFET is utilized as a switch in electronics and in power electronics. Particularly, MOSFET is acting as a switch and semiconductor switch in analog electronics and in power electronics. It is a very most common transistor and a prominent transistor utilized both in analog and digital electronic circuits also. Therefore, MOSFET is a prominent device in analog electronics, in digital electronics, and in power electronics. Therefore, the MOSFET is a very important topic for analog electronics also. Right, okay. How many types of MOSFET exist? The N channel MOSFET, N channel enhancement MOSFET, P channel enhancement MOSFET, N channel depletion mode MOSFET, and P channel depletion mode MOSFET. You mean enhancement mode and the depletion mode is nothing but the channel, how the channel, whether the channel is in depletion condition or in enhancement conditions. And the P and the N represents the majority carriers is the P and the majority carriers is in the channel is N. Again repeating, the majority carriers in the channel is P, then it may be a P channel, and if the majority carriers in is electrons, then it is an N channel MOSFET. Yes, okay. Okay, now let me see a construction here or a structure of a MOSFET. See here the pink color or a dark blue color. The pink or the dark blue color here shows the substrate or the body, whereas here it is a P. Whereas here it is a P. You mean the majority carriers is protons. The majority carriers is protons and the minority carriers is electrons. Therefore, a P type semiconductor is acting as a substrate. Whereas see here in the above the substrate, 2n channel, above the substrate 2n channel, a green color, 2n semiconductor is jointed or diffused here. The green color indicates the n type semiconductor where n stands for electrons. Therefore, the majority is electrons diffused as two parts, one in the left hand side, another one is the right hand side of the top of the substrate. N plus indicates the doping is high. You mean higher concentration of electrons is there in the green, dark green. And a metal, a black color metal is poured or diffused above the P, above the P in the gap, above the P, since it is a metal, right? Whereas the metal terminal is named as G gate, which is a heavily doped silicon, which is a heavily doped silicon, right? Therefore, here the possibilities of the channel, you can guess what may be the channel or what type of MOSFET is it. Can you guess it? As okay, see here, as it is an N channel. It is an N channel MOSFET because the channel is formed in between the P, the pink. The channel is formed in between the P, where the left hand side and the right hand side is 2n plus. Therefore, a channel has been formed or will be formed in between the n plus and n plus in the left and the right. And hence, this structure may be a n channel MOSFET. The structure may be the n channel MOSFET. The remaining terminals let we see in the next video series. Thank you for patient listening.